Now it is the last section of chapter 6, future importance. Its concept is quite straightforward. It is the increase in the model's prediction error after we permute the future's values. A future must be important if shuffling its values increases the model error. Because in this case, the model relied on the future for the prediction. A future is unimportant if shuffling doesn't change much. And so the more important feature will increase the error when the features are shuffled. Geometrically or intuitively is quite clear. Once consider a data set. So now each row is representing a data point, and now each column is a future. So for a future, we shuffle the values. So that we try to shuffle a column, then error will be increased. But it's more increase and a large increase in error means that here this value, the future is more important. So that's the concept. So it is called permutation future importance. And it is a kind of a future ranking algorithm. Look at the algorithm. For the algorithm, we need a trained model. And here, the future metric X is a data metric. And the label Y, and here, error measure. So first, by using all the data metric, we estimate the original model error. And for each feature from JS1 to D, for each one, for each column, we permit the column and to get here xj. And for xj, we try to estimate error. And now we calculate the permutation future importance, Fi, and either by using ratio or subtraction. Here, in any case, the error is larger than original one, then it'll be larger than 1, or in this case, it is positive. For each column, we measure this quantity, and then we try to sort by descending order, so that and the first one will be the largest error difference, which means that for the column, for the future, is more important. Once it is shuffled, then error is increased a lot, right? So that's the idea and simple algorithm. Here, when you are doing this permutation future importance, here there is a question: should you compute Fi on training or test the data? To answer the question, you need to decide whether you want to know how much the model relies on each feature. In this case, you may try to use training data. How much the future contributes to the performance of the model on unseen data, then you may try to use test data. There's no research addressing this question. However, in reality, every data point will be used for training, and trained model will be waiting for the unseen data, so that in most cases, you have to use all the data points to get the future importance. Okay. This is end of the section and end of the chapter. Thank you.